Okay, as promised, let's look at the other four functions. Let's start with cosecant, which you recall is 1 over sine x. And let's try to get the graph for this function simply by looking at our graph for sine x. So let's see. That is our behavior. Let's say I extend it for one more cycle for sine x. Right? It's capped at 1 and -1. That is y equals sine x right there. Okay. Now cosecant is 1 over sine. So let's look at some key values. For example, when sine is 1, 1 over 1 is 1. When sine is -1, 1 over -1 is -1. So 1, -1. So we know when sine x is 1, cosecant of that same angle is 1, and when sine x is -1, cosecant is -1. So these 4 points are for sure in the graph. But now we have a problem. When sine x is 0, what happens to cosecant x? Okay, recall 1 over 0 is not defined. But we can always look at what happens when you get closer to 0, right? So right here, let's follow this graph. That is 0. At 0, sine x is 0. So cosecant is going to be undefined, which means it can never have a value here. But what about these values? When you get closer and closer to 1, so like 0.1, this is 10. If it's 0.001, this is 1000. So it's increasing, which means you would expect that as you get closer and closer to 0, here, if this is sine, then cosecant is going to get larger and larger, but it's never going to touch this, because at 0 it's not defined. Then it becomes 0 again over here, so we expect a similar behavior, and it's going to go up and never touch. It becomes 0 again here. Now in this case, right here, it's at -1, and it's a negative big value. So it goes like that. Similarly, again, 0 right here. So it is periodic, but it behaves slightly differently. So these ones are the graph for cosecant x. So they can actually never be in 1 to -1, right? Their range is 1 to infinity and -infinity to -1. They are unable to take the value from or between 1 and -1. Use a similar analysis to get a graph for secant x from cosine x. Remember, secant x is 1 over cosine x. Now let's analyze y equals tan x. Tan x is sine x over divided by cosine x. So first of all, we know it's going to be undefined when cosine x is 0, which happens when x is pi over 2, 3 pi over 2, all of these. What we are going to call multiples of pi over 2. So we already have that at pi over 2, 3 pi over 2, it's not going to behave well. So at pi over 2, it's undefined. What about at 0? At 0, tan 0 is 0. So we have that. And then again, at pi, tan pi is 0. So you get a graph like that. Okay. Now you can try and perform the same analysis for y equals cotangent x using cotangent is cosine over sine. I'm going to do some of these. So negative tan x, which means you go from tan x to negative tan x. So that's the graph. You just flip it. This negative becomes positive and the positive becomes negative. Right? So and you can try these three graphs. I'll do one last example for 3 secant x over 2. A secant is 1 over cosine. So hopefully you did your analysis for secant. Right. So what's happening here is you are increasing the time period, and then you are also increasing the, well, not the amplitude, but if this is 3, it means it can only take values 3 and higher or negative 3 and lower. So it cannot take values between 3 and negative 3. So what's the graph for secant x? I do not remember it, so I'm going to draw cosine first. This is where cosine becomes 0. So right here, it's going to go like that. Right here, it's going to be like that. And right here, it's going to be like that. Okay, so I'm going to redraw here. That's 1. It's negative 1. Pi over 2 to pi over 2. So it goes like that, it goes like that, and 2 pi goes like that. So that's secant x. I go from that to x over 2 means everything is gonna stretch out, right? So this is 0, it's gonna stretch out to 4 pi. Right, so this is gonna stretch out to pi, and this is gonna stretch out to 3 pi. It's not gonna change my the amplitude value, so all it's doing is it's really stretching out my graph. And then finally 3 secant x over 2, all it's going to do is get this up and move this down to negative 3 and 3. Yeah, so you can see what happens. So once again, for graph transformations, all you want to do is go one transformation at a time, yeah, so that it's easy for you and you're not doing more than one thing at once. And you can play around in Desmos and see what the graphs for these functions would look like. That's it for week 1. You have 3 worksheets to work on, so you can start working on it as soon as you watch these videos. There's also office hours that you can stop by if you have questions, you want to go over some stuff, or there's some stuff that I missed. Yeah, that's it.